Assalamualaikum and hi, we from A4S120419. So today my friend, I would like to present about food quality control. Here our group members. So firstly is Amira Nafisa binti Azaman, second Nur Hafizah binti Gani, and the third is Nurul Shazwani binti Abdul Rahim, and next Nur Alia binti Muhammad Zahiri, and the last one is Nur Anisa binti El Hamra.
In this video, we will talk about introduction of food quality control, theory about application of titration, industry use titration, analysis of food product by using titration, example of food quality using titration, and lastly, conclusion. First and foremost is introduction. Food quality control use titration method to ensure that their product meets safety regulation and maintain consistent quality. But what is titration? Titration is a technique or procedure for determining how much of a dissolved material is needed to react with a known volume of the test solution in order to produce a specific result using the least quantity of reagent known as concentration. Titration for food quality control were used widely. Here, some uses of titration in ensuring food quality. Firstly, we have acid content measurement. Titration is commonly used to measure the acidity in food product. For example, vinegar, fruit juice, and sauce. The acid affect the flavor, preservation, and safety of this product. Next, we have salt content analysis. In products like cheese, butter, and canned goods, titration method is used to determine the salt content, which is sodium chloride. This is important for taste, preservation, and health regulation. Moreover, vitamin C determination. In products like fruit juice and dietary supplements have a concentration of ascorbic acid or called as vitamin C. The titration used to determine the concentration of ascorbic acid in the food is redox indicator. Last but not least, meat quality testing. Titration methods such as titrable acidity test are used to assess the freshness and quality of milk and dairy product.
Next, I would like to explain the theory about application of titration. So why is titration used? Firstly, titration is a proven method for testing substance in everyday use. It has a broad range of applications and is long established and reliable form of analysis. So, there are many common real-life applications of titration, which are determination of solution concentration, study of fraction kinetics, purification of chemicals, analysis of food products, and quality control in industries. Second, it is a form of detection that enables you to determine an unknown substance and its concentration within an analyzed solution. There are many situations in which it is important to make such a measurement. For example, it might be used to check the purity of a supplied chemical or to measure the level of impurity of a particular substance in a foodstuff. As titration involves careful measurements of the volumes of the solution used, and also known as a volumetric work. Lastly, it is especially useful for quality control and for measuring the precise proportions of chemicals and ingredients in various products and treatments. There are several titration experiments that can be performed for quality control purposes, and the exact one depends on the reactants, the type of reaction, and the intended products. For example, some manufacturers perform acid or base titrations when testing the concentration of reagents like stearic acid.
Now, I will present about how industry use titration in food quality control. First, fermentation control. In the production of fermented foods such as cheese, yogurt, and sauerkraut, titration is used to monitor the progress of fermentation by measuring acidity levels. Second, acidity and alkalinity measurement. Titration is used to measure the acidity or alkalinity of food products. For instance, in the production of beverage like wine, beer, and fruit juice, titration is used to monitor and control acidity levels, which is crucial for flavor balance and preservation. Third, quality control. Titration is used for quality control purposes to ensure that food products meet regulatory standards and maintain consistency in taste, texture, and nutritional content. And lastly, fat content analysis. Titration can determine the fat content in food products such as oils and dairy products. For example, in the production of margarine or butter, titration is used to measure the amount of fat present.
First and foremost is acid-base titration. This method is used to determine the acidity, pH, or alkalinity of food products. Acids such as malic, citric, acetic, and others can be found in fruit, juices, and vinegar-based food, among other things. It can be determined by titrating the sample with a strong base that neutralizes the acid present in it. Next is redox titration. This technique is used to determine the concentration of substances that either oxidize or reduce food products. A process called titration is one of ways to measure the amount of sodium chloride, which is salt, in food. In this process, a sample of the food is mixed with a solution of silver nitrate, AgNO3, that has been carefully measured. A chromate indicator is added to help identify when the reaction is complete. Moreover, colorimetric titration. This technique that relies on the intensity of color shift to determine the titration endpoint. In order to find chloride ion in a solution, silver ion are mixed with a standard potassium chromate solution until a reddish-brown silver chromate precipitate forms. This titration is performed using a strong alkaline solution. Once the acid in a food sample is neutralized, a phototruth sensor detects a precise alteration in color. Last but not least is titration method. This technique can be used to determine the concentration of specific ions or molecules. One way to measure the amount of chloride ion in food sample, such as cheese or meat product, is used to add silver ions to a standardized solution of silver nitrate. The silver ions will react with the chloride ion, forming a white silver chloride precipitate. This indicates that the titration is complete and the endpoint has been reached.
Next is the example of food quality using titration. First, acidity in fruit juices and soft drinks. It is to understand how it affects their taste and how long they last. The preparation is, first, they take a sample of the fruit or fruit juice or drink. Then, they add sodium hydroxide to it slowly until it changes color. This color change tells us when we have reached the end point of the test. By measuring how much sodium hydroxide we added, we can figure out how acidic the juice is or the drink is. This helps us know how much citric acid it contains, especially in fruit juices. The salt content in food products. It is to find how much sodium chloride, which is salt, they contain. This is important for their taste, how long they stay fresh, and for labeling their nutritional value. The preparation is, first, we mix the food sample with water, then we add a solution called silver nitrate to it slowly until we see a reddish-brown color appear. This color tells us we have finished the test. By measuring how much silver nitrate we added, we can figure out how much salt is in the food. Then, the vitamin C level in fruits and vegetables. It is to know how much of this important nutrient they have. This helps with labeling their nutritional value and ensuring their quality. The preparation is, first, we blend the fruit or vegetable sample into a smooth mixture, and then we take a small part of it for testing. We use a special solution like iodine or DCPIP to test it. This solution changes color when it reacts with vitamin C. We add the solution slowly until the color stays changed, and that tells us we're done. By measuring how much solution we use, we can find out how much vitamin C is in the sample. Lastly, the amount of lactic acid in dairy products. It is to understand their taste and texture better. This is crucial for products like yogurt and cheese. The preparation is, first, we mix the dairy product with water. Then, we slowly add a solution called sodium hydroxide until the mixture changes color. This color change tells us we have finished the task. By measuring how much sodium hydroxide we've added, we can figure out how much lactic acid is in the dairy product. These examples illustrate how titration is an essential tool in food quality control, providing accurate and reliable measurements of various important components in food products.
Lastly, conclusion. In summary, titration is an important in food quality control by ensuring that a wide array of food quality standards. By accurately determining the concentration of key substance within this product, titration safeguards consumers' health and uphold the integrity of the industry.